In this section, we're going to look at arithmetic and geometric sequences. The founder of a popular social media website is trying to inspire gifted algebra students to study computer programming. He is offering two different incentive programs for students. Option 1. Students will earn 1 penny for completing their first math, science, or computer-related college course. So they'll start with 1 penny. The amount earned will double for each additional course they complete. Option 2. Students will earn 1 penny for completing their first math, science, or computer-related college course. So again, start with a penny. For each subsequent course they complete, they will earn $100 more than they did for the previous course. Write an explicit formula for each option. So here's an overview of what's happening in each scenario. In option 1, they complete course 1, they get a penny. In complete 2 courses, 2 pennies. So every time we go up by 1 course, we're doubling. 3 courses, 4 pennies, 4 courses, 8 pennies. And eventually they get down to the point where they've completed 25 courses and they're going to get $167,772.16. Compared with option 2, where they start with a penny and every time they complete 1 course, they get $100 more. So we're adding 100 each time. So 2 courses, they'll get 101. 3 courses, they'll get $200.01. 4 courses, they'll get $300.01. All the way down to 25 courses, they'll get $2,400.01. And it wants us to write an explicit formula. So for option 1 here, to figure out the amount of money, it looks like you're taking the previous amount and timesing by 2. So you have to take the previous amount. So if we're trying to find n, the one before it would be n minus 1. And you multiply that by 2. For option 2, to figure out the amount of money, you need to take the previous option and add 100. So if we want to find a sub n, the previous option would be a sub n minus 1. And then we add 100 to that. So in option 1, we're doubling. Option 2, we're adding $100. Compare the 2 scholarship options in the graphs below. So you'll see here in option 1, really, really small values until about 19-ish, and then it seems to skyrocket. Whereas option 2, there's just a gradual increase the entire time, makes a perfectly straight line. Option 1 is considered to be a geometric sequence. This means each term is the product, so multiplication, of the previous term and 2. So 1 course was a penny, 2 courses was 2 pennies, 3 courses was 4 pennies. So every time we add a course, we're taking the previous amount and doubling it, multiplying by 2. The geometric sequence follows a multiplication pattern. And evaluate the domain. So the domain would be the different numbers they're plugging in. So in this case, the domain would be the different numbers of courses. So they could take 1 or 2 or 3 or 4 or so on and so forth, and it looks like it stopped at 25. So domain would be the different number of courses. Option 2 is considered an arithmetic sequence. Each term is the sum of the previous term and 100. So if you think back about the table that was on the other page, one course was a penny, two courses, you got the $100 and a penny, three courses, $200 and the penny. So each time you were adding 100. Arithmetic sequences follow an addition pattern. Evaluate the domain of this function. So domain, again, is the different numbers they use for x. So in our case, that'd be number of courses. So they had one course, two course, three course, four course, so on and so forth, and it looked like it stopped at 25 again. What can be said about the domain of arithmetic and geometric sequences? Well, it looks like it can be a list of numbers. So they can be a list of numbers. Consider the two scholarship options for studying computer science. Which scholarship option is better if your college degree requires 10 math, engineering, or programming courses? So if we look back at our chart, 10 courses for option 1, you get $5.12. 10 courses for option 2, you get $900.01. So option 1 or option 2 it is. If your degree requires 25 math, engineering, or programming classes, which option is better? So we look at our table. 25, you're getting 167,000. Option 2, you're only getting 2,000. So option 1. Do you think these graphs represent discrete or continuous functions? So remember, discrete, that means your x is something that you count. And continuous, your x is something that you measure. And we're going to count the number of courses, so this was discrete. Because you count courses. So we would not be able to have all the fractional pieces that you would get from measuring something. So it's not continuous because we can't have all the partial pieces. So we're counting them. We need whole numbers. Do you think option 1 would ever be offered as a scholarship? Why or why not? Probably not. They're giving away way too much money. It'd be nice though. Let's try another one. Pablo and Lily are saving money for their senior trip next month. Pablo's goal is to save 1 penny on the first day of the month and to triple, so that's times 3, the amount he saves each day for 1 month. Lily's goal is to save $10 on the first day of the month and increase the amount she saves by $10 each day. So because it's going up by the same exact dollar value, that would be addition. So Pablo is going to be multiplying by 3, and Lily is going to be adding 5. Pablo's saving plan is an example of, well, he's multiplying by 3, so that's geometric. And Lily's saving plan is an example of, she's adding 5, so that would be arithmetic. Which person do you think will be able to meet his or her goal? Explain. Well, if Pablo's tripling his money, he's going to end up saving more. So he's probably going to be the one to meet his goal. So Pablo, because he will save more money. So things that are growing through multiplication will eventually catch and pass things that are growing through addition. Circle the best answers to complete the following statement. Arithmetic sequences follow a linear or an exponential or a quadratic pattern. So linear would mean you're having constant rate of change. So a constant rate. Exponential would mean you have a constant ratio. And quadratic pattern would mean you have a constant change of change. So a constant rate would mean you're adding the same amount every time. A constant ratio would mean you're multiplying the same amount every time. And a constant change of change would mean that when you look at how the change changes, it would be constant. So arithmetic sequence, you are adding the same amount every time. So that would be a linear. Whereas geometric sequence follows a geometric sequences have constant multiplication, which would be an exponential. And the domain of both sequences is a subset of integers, so positive and negative whole numbers. On Sunday, Chris and Caroline will begin their final preparations for a patio recital the following Saturday. Caroline plans to practice 30 minutes on the Sunday prior to the recital and increase her practice time by 30 minutes every day leading up to the recital. Chris plans to practice half of Caroline's time on Sunday, but will double his practice time every day leading up to the recital. List Caroline and Chris's practice times on the tables below. So Caroline is going to start with 30 minutes, and she's going to increase her practice time by 30 minutes every day. So because she's adding the same exact amount of time, she will be adding 30 minutes. So if Sunday is the beginning of time, so 0, she's going to practice for 30 minutes. On Monday, which would be like the first day after, see what you can come up with for this table. So Monday will be 60, Tuesday is 90, Wednesday is 120, Thursday is 150, and Friday, which would be 5 days after she started, should be at 180 minutes. So every time we add a day, we add 30 minutes. Chris, he plans to practice half of Caroline's time on Sunday. So if she did 30, he's going to do 15. But we'll double his practice time every day leading up to the recital. So if he starts with 15 minutes and then he doubles that, he'll be at 30. And then Tuesday, see if you can continue this table. So he doubles, he'll be at 60. 60 doubled is 120. 120 doubled is 240. And then by the 5th day after he started practicing, he'll be at 480 minutes. So by the 5 days out, he'll be practicing 300 more minutes than her a day. Compare the graphs of Caroline's and Chris's practice time. Identify each graph is linear or exponential. So when we made Caroline's table, we added the same number each time, which makes this arithmetic. And when we graph it, we get this perfectly straight line. So hers is linear. When we made Chris's table, we multiplied by 2 each time, which made this geometric. And we look at his graph, we can see it bows and curves up, so his is exponential.